With someone who is coming from England.
Harry Roberts helps some of the world's largest and most respected organizations find and fix their site speed issues. He's both Google and Cloudinary Media Developer Expert and has consulted for clients from the United Nations to the BBC, from General Electric to the Financial Times, and a whole host more.
Harry is more famous for his wizardry. That's why everyone calls him CSS Wizard.
Today, Harry is here to talk about... Well, no one knows exactly what Harry is going to talk about. His talk is complete mystery.
Let's dive into his magic lecture.
Lecturus expectum, Harry Roberts!
Unreal. That's the best intro I've ever had. Yeah, that is a good point, actually, because I looked at the agenda, and it doesn't actually say what my talk is. It just says a keynote. One thing you're about to find out is I'm not a particularly inspirational person. I'm probably maybe a useful person. So what we're going to look at today is site speed optimization and web performance. The talk is called Get Your Head Straight. And the talk, somewhat predictably, begins around 3,500 years ago. It begins with something known as the cardiocentric theory. The cardiocentric theory was the belief popularized by the ancient Egyptians that the heart was the single most important organ in the human body. They believed it controlled emotion, thought, intelligence, feeling. And they believed this for a very, very, very long time. This belief was sort of held for thousands of years. They believed the heart was so important that it was the only organ left inside the chest cavity when ancient Egyptians were embalmed. After they died, they passed on to meet the god of death, Anubis, who would then weigh their heart against a feather. If the heart was lighter than a feather, they got to go to heaven. Now, we all know that the heart isn't the most important organ. There's no such thing as the most important organ. They all have to work together. But it wasn't for another several thousand years, in fact, no, it's just over 1,000 years, that somebody came up with the idea of the cephalocentric theory. And that someone was Hippocrates. He put forward the idea that maybe the brain is more important. But again, we know that the brain isn't more important. Every organ's vital. But this theory never caught on. It took 1,000 years before somebody presented it, and nobody really believed it. No one listened. It wasn't until this English dude in the 1500s put forward the idea that actually the heart is important, but it has nothing to do with thought, nothing to do with intelligence, that people finally started putting a focus on the brain, what goes on inside the head. So what I want to talk to you about today is something very similar that I see in web development. I'm a consultant web performance engineer. What that means is I work with clients to make their websites faster. One of the most interesting places I find to do this is right there in the client's head tags. So over the next sort of 20, 25 minutes, you are going to learn way more than you ever wanted to know about head tags. I'm obsessed with them. They hold the key to a lot of sort of web performance issues. And what we'll do is we'll dissect and look at a lot of the problems that happen in this part of a web page. The thing I find most interesting, this is the only bit of a web page that a user will never actually see. And because of that, developers don't tend to focus on it enough either. This talk is going to make you as obsessed as I am with head tags. This is a slightly shorter version of the talk. I will share the full slides. I'll tweet them or I'll put them online at the end. This is a slightly shorter version of the talk, but there are two really quick key concepts I want to remind you of. The first is that HTML is parsed line by line. It's completely declarative. There is no control flow. There's no logic in HTML. This actually makes it very reliable, very predictable, and very, very fast. So this is a feature. This is a really good thing for web performance, but it's going to be really important for us to remember during this talk, HTML is parsed line by line, and that influences a lot of how web pages work. The second thing I want you to remember, the head is the single biggest render blocking part of your document. And you kind of just have to believe me on this, but if we take the first point, HTML is parsed line by line, we can use that to prove the second point. If HTML is parsed line by line, and obviously lines are just a human construct, computers don't actually deal with lines at all. If HTML is parsed line by line, and the only bit of a page a user sees is in the body tags, the browser has to get to the body tags before it can display the page. In order to get to the body tags, it has to finish the head tags. So because HTML is parsed line by line, we can't begin rendering a single thing until we finish the head. That makes the head entirely render blocking. That's why we need to optimize it. A few times during this talk, I'm going to tell you to take pictures of the slides, of the screen. So if you get your phones handy, just take photos so you've got a reference. You may want to take a picture of this slide, but basically what I've done is I've created the world's slowest head tags, which felt like a bit of a waste of time because most of my clients did this already. But I've done it again. What I've done is I've created the world's slowest head tags. And what I've done here is I've actually not invented anything weird or outrageous. I've taken a series of real examples of things I've seen on actual client projects and just added them all together, and it makes a really disastrous outcome. You'll be really surprised by just how bad it is. Again, this is another slide you might want to take a picture of. This is what? 42 lines of HTML. Don't shout out, but just have a bit of a thought. Is there anything on this screen that seems weird that you think, well, that's a bug, or that's a problem, or this is going to cause issues? Of course, we've got, on line 24, we've got a script block that runs for 5 seconds. That's definitely going to be slow. But yeah, oh no, sorry, it runs for 1 second. But there's not really sort of that much strange going on here. Some style sheets, some inline scripts. Content security policy, we've got a cross-site request forgery token. This is all stuff that exists on real websites. This is all stuff that I've seen on client websites. But the outcome of this is really, really surprising. These head tags look like this. Now, if anyone hasn't seen one of these graphs before, it's really quite easy to understand if you use like Tetris, the computer game Tetris as a metaphor. The whole point of Tetris, if we were to turn this graph that way around, we'd be doing really badly at Tetris. What we're going to do is, during this talk, optimize this graph so everything crams up to the left. What we want to do is pack all these things really nice and tightly together. What we can see from this screen is that everything's really spread apart. From left to right is elapsed time. How long did it take to solve the head tags? That simple 42 lines of HTML took 9.3 seconds. It's a complete mess. What we're going to do is step through together and refactor each individual bit of these head tags and see what improvements we can make. My first bit of advice is don't be so big-headed. If you can remove it from the head tags, remove it. There's a lot of stuff probably in there that doesn't need to be. If it doesn't need to be in the head, get it out of there. That could mean a lot of different things. It could be things as simple as redirects, inefficiencies in your head tags. A redirect in the head's a very expensive place to have a redirect. Your Facebook tracking pixel probably doesn't need to go in the head tag. It can probably go in the closing body. Any deferred scripts don't need to go in the head. They can go near the closing body. Your mileage will vary, but there's some stuff that will be in your head tags that you could probably remove. So first thing we've got here is this redirect. We're pointing to an asset that lives somewhere else. So immediately, in that render blocking phase, we're incurring a redirect. And we can see from the screen here, that redirect is costing us 492 milliseconds. So if we remove it, the site should get 492 milliseconds faster. Now, you're probably thinking, a lot of you are probably thinking, no one is stupid enough to put a redirect in their head. And most people aren't. But the simplest way it creeps in is stuff like this. What we're doing here is linking to the latest, so this isn't a sender, this is like a variable. We're linking to the latest jQuery on unpackage. Unpackage is going to actually redirect us to a sort of version-locked something.something.something. I've seen this a lot of times in client projects, and that's costing us this redirect. So top and bottom, we've got before and after. What I find quite interesting here is the redirect was costing us 492 milliseconds. We get rid of it, we should be 492 milliseconds faster. This is the first bit I've got to admit. Performance engineering and sort of testing is a bit non-deterministic. So actually what happened, I removed that redirect. The site didn't get 492 milliseconds faster, actually only got 41 milliseconds faster, which is annoying. There's a lot of variable and variance in performance engineering, performance testing. I don't have time to explain my methodology in the talk, but the tests were very rigorous, and I've not done anything to massage the figures. I've made sure everything's honest. If you're interested in my testing methodology, we'll talk about that over a beer. It's really boring, so we'll definitely need a beer. Next thing is self-host whatever you can. Again, this is a short version of the talk, so I don't have time to go into it, but just trust me, self-host whatever you can. Don't use cdn.jquery or whatever it is, code.jquery. Don't use unpackage, don't use any of that stuff. If you want to know exactly why, I've written about it in great detail here, but just self-host everything. So if we do that on this demo head tags, what we're gonna do is we're gonna save all this time here. It doesn't look like a lot, but it's pretty easy to save. What's highlighted here is the time involved, or the cost involved, in going to a different domain. And that's quite a lot of time we're just wasting. By getting rid of this, by self-hosting these files, we got 377 milliseconds faster. Anyone in the room who doesn't do much performance work probably thinks that 377 milliseconds is pointless. What's the point? I worked with a client in the UK a few years ago, and we worked out if we could make their site 300 milliseconds faster, they'd make an extra £8 million a year, which is roughly 8 million euro, just a bit more. These are big numbers. Imagine making your client 8.5 million euro just by self-hosting a few files. How wild is that? So yeah, dead easy fixes that could be, to the right people, worth a lot of money. Get your head checked out. This is a really interesting one. When was the last time anybody validated their HTML? One person. We'll get a beer later. We don't really do it anymore, and we don't really need to. We don't need to. But it's something I do quite a lot because invalid head tags can cause you problems, especially where web performance is concerned. There is a fixed list, it's a finite list of elements that are allowed inside your head tag. If you put any disallowed or illegal elements in your head, something quite interesting happens. So in the demo I've got here, we've got this input type equals hidden for the cross-site request forgery. Inputs are not allowed in the head tags. Most elements are not allowed in the head tags. And what happens if the browser encounters an illegal element is it panics. And on the fly, it will close your head tags early, just before the illegal element. In effect, pushing everything else into the body tags. This is a really good example of the difference between your HTML and your DOM. Your HTML is invalid, but the browser's on the fly corrected it in the DOM. What this means now is all these things that were in the head, in this render blocking phase, are now pushed into the body, which means there are implications about when we start rendering and how things get requested. Everything's still in the correct order, that's useful, but it's in the wrong place. What happened now when I reran the test is things got very, very interesting. We got 12 requests before, 11 after. So fixing the head tags got rid of a file. And I was like, how has that happened? What this actually did is it highlighted a bug that then made the rest of the talk even more interesting. Don't worry, it does get more interesting. So yeah, fixing these head tags got rid of this file, and we'll come back to why that happened in a second. When I reran the tests, it got slower. I was like, oh shit, that's not what I wanted to happen. But like I said, I'm not here to massage the figures, I'm not here to invent numbers. This actually got slower. That's because if we push half of the stuff out of the head into a non-render blocking phase, the site will be faster. If we move it back into the head and make it render blocking again, it makes sense that it would get slower. I'm of the opinion I'd rather have valid, predictable HTML than invalid and faster. At least it's then predictable. Get your phones ready, because what's kind of weird is when I was writing this talk, I started with one slide that was like, that is the talk. The next slide I'm about to show you basically is the whole talk. Everything before it, everything after it is just me, spending time on stage. The next slide is the absolute perfect head order, right? This is the whole point of the entire talk. The last risk there was to remind me to tell you that this is theoretical purity. You may struggle to refactor onto this very quickly. Any brand new project, this is going to be easy to do. Any existing project, it might be a little more difficult. What we're going to do is all the things in white are render blocking, so we're going to talk about those in the talk. This is a short version of the talk, so anything in gray I won't discuss today. If you want to talk about these, again, let's grab a beer, let's grab a coffee and talk about it then. All right, so the first point is about metadata about the page. How should the page be processed? What I'm going to do is I'm going to deep dive into this, talk about a specific meta tag, then I'm going to come back up and talk about meta in general, which in itself is quite meta. So, Meta CSP disables preload scanner. Hands up, who has ever implemented a content security policy? Oh, you lucky, lucky people. It's an awful job. Yeah, you again. We're like the same person, right? CSP, it's awful because you soon realize, oh my goodness, my site is really liable to all these things. A CSP, content security policy, is a policy defined by you, the web developer, or the site owner, that basically tells the browser, you can request JavaScript from here, but not from there. And it's a security thing that means things can't get injected into the page without you approving it. You normally deploy this with an HTTP header, but what you can do is you can put a meta tag in the head of your page, the HTTP equivalent meta tag, and if you do that, it's going to be a real mess. I need to quickly tell you about the preload scanner. The preload scanner is a feature in all modern browsers that basically makes your downloads asynchronous. Back in the olden days, i.e. 7 and before, downloading and parsing of the page was done by the same parser. What that means is the parser or the browser can't build the page while it's downloading resources for the page. It's really slow. IE8 invented something called the speculative pre-parser. Microsoft, it had to sound enterprisey. Everyone else just calls it the preload scanner. And this made websites way faster, for free. Developers don't need to do anything to benefit from this. It's just there for free. So back in the olden days, downloading 4 JavaScript files would look like this. And again, think of the Tetris analogy. That's not a very good game of Tetris. As soon as Microsoft invented the preload scanner, it looked like this. All those files get downloaded in parallel. This is way faster for free. Developers didn't need to do anything to take advantage of this. Unfortunately, content security policies in the head turn this feature back off. This was a client of mine. Can you all see that? This is a client of mine from sometime last year, and they controlled hundreds of blogs. They were like a big publisher, and they owned hundreds of blogs. And all of these blogs were exhibiting this really strange behavior. All of them were starting to render really late. So I ran a test, and nearly all of the waterfalls look like this. And you can see, what is it, lines sort of 2 through to 9. We've got a nice vertical, or 10, I guess, nice vertical downloads. Tetris is going well. Then after sort of line 10 and 11, things get really stretched out, really dragged out. What I thought is, well, we've got a lot of third-party assets here. Maybe it's a third party that's causing the problem. So I ran the test, blocking any third-party domain. I thought that would make the problem go away. It actually made the problem way more obvious. These orange files here, clearly, they just look like a flight of stairs, right? I was looking at this wondering what on earth was going on. And at first, I was thinking, maybe each JavaScript file injects the next one. But I checked, and that wasn't the case. And then I was like, oh, I've seen this before. Because I'm quite old. I saw this back in IE7. And I was like, that can't be right. This is IE7 kind of behavior. So what I did is I read, line by line, my client's head tags, and I found this about halfway down. They got a content security policy halfway down their head tags. So I was thinking, well, maybe that's got some kind of effect. So I deleted this line in DevTools, refreshed the page, and the problem went away. So I went and did some digging, and I read the source code for the preload scanner in Chrome. And sure enough, it says, don't preload anything if a CSP is encountered. I haven't found out why they do this. I need to ask someone why, but this is basically what was happening. I asked a friend of mine to actually run a query of the HTTP archive to find out how many sites this affected. Luckily, it's not many. Not many websites are doing this. On desktop, it's 7,000. On mobile, it's 8,500. So it's not a lot of websites affected. Interestingly, the majority of those websites are probably the client of mine. And because we fixed it, that number should be a lot smaller now. So by moving the CSP to the very first thing in the head, we got some really staggering changes. So before, we've got this staggered stair step, and we've got how many? We've got 11 requests. By moving the CSP, we start to bunch things up a bit tighter, which is nice, but we go down to 8 requests, 8 files. That weird head tag bug I told you earlier is related to this. The reason we get the parallelization is because we get the preload scanner back. The reason we lose some requests is really, when you think about it, it's quite obvious. Content security policy tells the browser how or what files it's allowed to download. HTML is parsed line by line. If you put your CSP in the middle of your head tags, the browser's going to request a few files, like without the CSP applied. Then it's going to find the content security policy and panic and think, oh no, I just downloaded a load of files without knowing about my security policy. I'm going to have to re-download them all again and double check. So that's why we get the double downloads. Moving this one line of HTML to the top of the head tag made this page 3.7 seconds faster, which is wild. When I fixed this problem for my client, they were so happy because they had no idea what was going on. They had no idea what was going on, and all it was is a developer was tasked with implementing a CSP, and the developer just put it in the middle of the head tag. It's an innocent thing to do. It's not even a mistake, really. No one ever told anyone to put it at the top. It took me a long time to find this out. So 3.7 seconds, pretty good. Metadata about the page goes first. So the CSP is a very specific sort of download queue. Metadata about the entire page, this is like how the page should be dealt with, that goes first. The two asterisks here are to remind me to tell you, I'm not talking about SEO meta tags. I'm not talking about your open graph meta tags. Metadata about the page. So things like your character encoding. Tell the browser how to deal with the page. So your character encoding, the spec actually says it needs to go in the first 1 kilobyte of your HTML. To make it even easier for yourself, just put your character encoding #1 in the head, right? Just put it at the very, very top. The meta viewport for responsive design, that technically can go anywhere inside the head, but there's an interesting thing that happens if you put it outside of the head tag. So remember I told you if we had invalid head tags and stuff gets pushed into the body, if your meta viewport gets pushed into the body, what ends up happening is the browser starts rendering the page, then sees the page should be responsive and has to re-render it all again, a little bit like this. So unresponsive, then it finds the meta viewport and repaints the entire page. That's really expensive. We need to avoid that. The next thing, don't hide the title. So your title tag is often the very first thing a user might encounter, especially on desktop when you've actually got browser tabs. There's a really, bless you. There's an interesting behavior here. Because HTML is parsed line by line, the browser has to deal with line 3 before it even knows that line 4 exists. If line 3 was a particularly expensive script, we run into a potential problem. Well, not potential, a definite problem. I'm about to show you a little screen recording. What I want you to do is pay close attention to the tab in Chrome. URL, not rendering the page, not rendering the page, then everything renders. The title tab and the H1 both render at the same time. That script was blocking the discovery of the title tab. That script only took 2.5 seconds, well only, I forced it to be 2.5 seconds. If you ever have a third-party outage, let's say, I don't know, Optimizely has an outage, it takes 1.3 minutes for Optimizely to time out. So it could be a case of it takes 1.3 minutes before a user even sees the title of the page. The fix here is really, really, really simple. Swap those around. The script is still going to take as long as it needs, but now watch what happens with the tab in the browser. Immediate feedback. The page isn't rendered until sort of now, but the tab in the browser at least gave immediate feedback. So my advice here, don't put anything synchronous in front of your title, because you're just going to slow down that feedback for the user. Rearranging metadata didn't change the shape of the waterfall because it didn't affect any files. All we affected was metadata, so the waterfalls look pretty much identical in terms of their shape. However, it did get 280 milliseconds faster. Just by moving the metadata around, we gained over 1/4 of a second. That is huge, just for nudging some lines of HTML around. Okay, here's where it gets interesting. Synchronous JavaScript goes before synchronous CSS. Developers hate me for this. CSS is render blocking, right? And we want to focus on loading CSS as fast as we possibly can. So whenever I tell developers to do this, they don't trust me, and I have to kind of prove it to them. Your JavaScript should go before your CSS. There's a really simple but very annoying reason why. CSS blocks the execution of JavaScript. If you've got any in-flight CSS, any JavaScript defined after it will be blocked until the CSS is finished. The reason for this is really simple, but it's an edge case. 99% of the time, this behavior isn't desired, but the browsers are designed in such a way that they won't break for that other 1%. Imagine an example like this. We've got a style sheet on line 1, and then on line 4, we're just asking a CSS question, right? We're just asking, what is the color of the page? Now, if this was an asynchronous operation, we've got a race condition. We might ask the browser what color is the page before the CSS has landed, so we could get a stale or an incorrect answer. It's a simple race condition. Browsers don't know what the script is doing until it's done it, so there's no pre-parser for scripts. So what the browser does is it defensively it sort of thinks to itself, well, okay, I'm downloading some CSS, there's a script coming up, that script might ask about the CSS, so I'll block the script until the CSS is finished, then I'll run the script. It's defensive. 99% of the time, you don't need this behavior. This is a bit of a weird example. Where it actually affects web perf is examples like this. We've got these async snippets. Third parties give us these all the time. While ever that CSS is downloading, that async snippet, that third-party script, is not going to run. What that means is our waterfall looks like this. That JavaScript file wasn't even discovered until the moment the CSS is finished. This is really, really slow. All we need to do here, all we do is swap those two blocks around, and all of a sudden, everything gets way faster. Complete parallelization. A very good example of this is Google Tag Manager. Google Tag Manager tell you, paste it as the very first thing in the head. And all the web developers out there, they sit and think, piss off. I'm not doing that. You're not going at the top of my head tags. My CSS is going at the top of my head tags. Tag Manager isn't doing this to capture more data. It is genuinely the fastest thing to do, so we should trust them. But there's a caveat. If you do that, if you put your JavaScript first, the JavaScript is now going to block any CSS imports. So we've got a bit of a battle here. Who's going to win? This is currently a bug, in my opinion. It's a bug in Chrome. But of course, if you're me, I call it a bug. If you work at Chrome, you call it a feature. So the other battle is me trying to get Chrome to fix this bug, and nope, it's a feature, leave it as it is. Basically, imagine the scenario. We've got a synchronous JavaScript file on line 3. On line 4, we've got a CSS file that imports another CSS file. The waterfall for this is really dragged out. A very strange behavior. That second CSS file there is completely divorced from the first. The first file imports the second CSS file, but that entire chunk of JavaScript sits in between it. It's a really strange bit of behavior. In fact, if you ask me, that waterfall looks as though the CSS is requested by the JavaScript file. Not the case. The reason for this is very, very interesting. Browsers are single-threaded. They can only do one thing at once. So if it's got a JavaScript file defined first, it has to run the JavaScript before it can parse the CSS. So what happens is the browser has to download, parse that synchronous JavaScript file. Only then can it open the CSS file and find out that, there's an @import right at the top. It doesn't get to dispatch that import until it's finished the scripting task. So the fix here is swap those around. Now, all of a sudden, our waterfall is back to being pretty parallel, much, much faster. By the way, you're probably thinking, I'm not meant to memorize all this, am I? There's a thing at the end where you don't need to memorize a thing. So I've got a little tool that I'm going to share with you. Start render is now way, way faster. Quick example of this going wrong on a real site was on the Vans Canada website. I'm really sorry, this kind of text is pretty small now I look at it. The Vans Canada website was slowed down by 9.3 seconds because of that huge JavaScript file in the middle of the head. So the Vans website had a load of other problems as well as this, but here is that exact bug in action. I did open the bug. This used to work, actually. This used to not be a bug. It's a regression, so they could add the fix back in. But yeah. So rearranging my CSS and JavaScript to abide by these rules, we see that Tetris game, we're getting better and better at it. Things are really tightly packed. Just by reordering our CSS and JavaScript, we've saved an extra 1.65 seconds. I haven't refactored anything here. I haven't rewritten on a different sort of framework. I've not refactored the CSS to be smaller. I've just moved some lines of HTML around. The next thing is the import that I mentioned. Don't use it anyway. I'm going to have to start hurrying up because I'm sort of running out of time. Import in CSS is an anti-pattern. We should not use it anyway. Like, just don't use it. So what I did is I refactored my code to remove the import and had a second link rel equals style sheet, and I saved this much time. So that file there now starts in parallel to all of the others. That saved me another 3/4 of a second. All of this is adding together to save over 6.5 seconds of time, just by nudging some lines of HTML around. One really important thing that I need to address is SEO, because every time I talk to companies and clients about this, somebody in the marketing or the SEO department gets really scared. SEO and social, your open graph, all that kind of stuff, that goes at the bottom of the head. That just goes last. Most social stuff is asynchronous, especially meta tags, like I don't know, descriptions or your open graph stuff. But it needs to just go last. The way I prove this to SEO people, to marketing teams, is HTML is parsed line by line, right? If it's parsed line by line, well, actually, no, I'll rewind a little bit. Most SEOs tell me I can't put my SEO stuff at the bottom of the head, because what if Googlebot never finds it? If there's all this stuff in the way, what if Googlebot never finds my SEO stuff? Googlebot is a browser. It parses web pages the same as any other browser would do. Because HTML is parsed line by line, if Googlebot can't find the bottom of your head tag, it can't find the start of your body tag. So you've got way bigger things to worry about. So realistically, SEO stuff, it doesn't matter where it goes, and in that case, put it last. Googlebot will always find it. Actually, not always. I found this interesting bit of information. Googlebot, it will crawl the first 15 megabytes of HTML as uncompressed HTML. So if your page is bigger than 15 megabytes, don't worry about SEO. Worry about your 15 megabyte homepage. So Googlebot is guaranteed to find that information. There's some interesting caveats with Open Graph. When you paste a link into Slack or you paste a link into WhatsApp, you often get the little preview, right? Like maybe an image or a URL, the title of the post. A friend of mine did some research. Twitter, if you share a link, does a full GET request. So Twitter will request the entire HTML and look through 100% of it for the Open Graph, Twitter card sort of stuff. Slack does the first 32 kilobytes. So if you're desperate to get your card previews in a Slack channel, when someone shares a link to your site, it needs to be in the first 32 kilobytes. WhatsApp, it needs to be in the first 1 megabyte. You are never going to hit these limits. They're enormous numbers. So yeah, SEO, social stuff, that goes very, very last. So now we've refactored all of that, we've got this new order. First contentful paint was, I think, around 9.3 seconds, I think it was. Now, first contentful paint, we've begun rendering at 2.6 seconds from 2.7. Just by reordering a few lines of HTML, we've saved 6-point-something seconds. This is a huge number. Every brand new client project I start in the head. It's where some of the easiest optimizations exist, and they can have a tremendous effect on web perf. The new order of the page looks a little like this. It doesn't look particularly different, actually. It's a bit neater, perhaps, but the same stuff is all there. I haven't removed any features. I haven't deleted any dependencies. So all the same files that were there before in a much tighter order, which leads to a before and after that looks like this. This is the kind of stuff that really makes it different for a lot of companies, especially e-commerce. If anyone's working in e-com, you'll find that this stuff really makes a huge difference. But yeah, just nudging a few lines of HTML around, we saved over 6 seconds. So one thing I said to you was, you don't need to worry about memorizing any of this. Going back to the awkward medical history analogies, there's a whole reason I started with the ancient Egypt stuff, by the way. It's to make me look quasi-intellectual. You may have heard of computed tomography, or CT scans is what we more commonly know them as. When I was researching this talk, and indeed when I was doing this kind of work on client websites, I kept thinking to myself, like, this is a lot of stuff for me to memorize, a lot of things to kind of hold in my brain at one time. So what I wanted to do is have a CT scan, but for web pages. I don't know if anyone's been in one of these machines before, they're not very pleasant, but these are really good at getting a quick look inside your head. I want the exact same thing for a web page. So as a little side project one afternoon, I built something called ct.css. And what this does is a bookmarklet. If anyone remembers bookmarklets, you could install it via NPM, you could add it to your project however you like. What ct.css does is it uses a small CSS snippet, which, by the way, is the worst language to bust syntax. CSS is not suited for this kind of job. It was just a project for fun. Now what I can do on any website, I can just add ct.css via DevTools or via a bookmarklet, and it'll do this. And it'll tell me that inline script, nice and fast. Your title is blocked by JavaScript. This JavaScript is blocked by CSS. I can just click this, and I'll get a visual display of all the problems on the site, and I can just refactor the head tags until all these go away. Red, orange, green signify the severity of the problem. Green is, no, this is fast, leave it as it is. Red is, this really needs solving, this is slow. If a box has a solid line, it means this box is the problem, or this asset, this file. If a box has a dotted line, what that means is this file is affected by something else further up. So what it means is you can tell if something's the target or the subject of a performance slowdown. This is the demo page for ct.css, so this was designed to be quite slow so that I could demonstrate it. I ran the CNN website through ct.css, and it broke ct.css. I feel a bit sorry for CNN. Every single performance talk in the world uses them as an example, and I feel a bit bad that they get picked on. But then I think, hang on, they could have the fastest website in the world if they just attended conferences. Everyone's on stage doing the work for free. CNN, start sending your developers to conferences. Yeah, so that is ct.css. If you want to have a play around with it, if you do much web development and front-end work, it's a really easy tool to get started with. You can just, like as I npm install, or you can just add it with a bookmarklet, ct.css. Yeah, go and have a play around. But with that, I just want to thank you for your time, thank you for your attention and patience. If you've got any questions, I guess I'll be around for the rest of the afternoon, so thank you very much.
So, any questions?
Do we have any questions now? I'm happy to take any and all questions.
Questions for t-shirts?
So,
Yeah.
your friends?
Yeah.
The guy with the beer.
We should get a beer later. We've got everything in common.
Yeah, thanks. So I have tons of questions, but just one question for now. How do you consult a company that's actually using CMS, content management system, to work with their websites where they don't have so much control over their head tags?
That is a really good question. So one thing I mentioned is this is theoretical purity. You will get blockers where, I've got a client at the moment using Next.js, and Next.js makes a lot of very opinionated decisions about how your head tag should look. At a point, or it could be a CMS, like Magento does some really opinionated stuff. When you get to that problem, you're kind of stuck. There isn't much you can do. You could patch it locally, but then you've got to maintain a fork. You could submit a feature request or a pull request with the CMS in question, but that takes months. I won't go into detail now, but there are some other measures you could take. So you could write almost like bridges that will sidestep some of the issues. They're a bit too specific to answer right now, but you could do things like preloading files a different way or pre-connecting origins, but it would depend on the use case specifically. But yeah, I guess two-part answer is there are certain very specific mitigations you could make. And the second answer is you're kind of just out of luck. If the CMS is very opinionated, and this is the thing, right? People don't focus on head tags enough. So a lot of CMSs just sort of say, you get what you're given, and you can't make many modifications. And in those scenarios, I tell clients, look, let's just optimize elsewhere.
Thanks.
Any other questions for now? Okay, thank you.
Oh, there is one just there.
Okay.
A short question from my side. Did you use some kind of tool for performance testing, maybe in some situations?
The one tool I use like 10 times a day is called web page test. Web page test is those really ugly graphs. So one thing that I really like about my job is that I'm a nerd so much that my clients are terrified of that, because look how ugly it is. So that's the tool I use more than anything, and it's because my clients have got no idea what they're looking at, but I do. That's called web page test. All web page test is a very ugly wrapper around DevTools. So ultimately, every time I'm using this, I'm just using DevTools. Chrome's DevTools is arguably the most powerful for performance testing. But if you're optimizing in Chrome, obviously you're missing every other browser. But webpagetest.org is the tool that I use like several times a day. Things like Lighthouse are really powerful, but I feel like Lighthouse, that's good for explaining web perf to non-technical stakeholders, telling them a number. For really forensic optimization, for forensic insights, web page test all the way.
Any questions?
Cool. Well, if anyone does think of a question, I'm going to be around with coffee and beer and stuff later, so just come and find me. But is that us done?
Yeah,
Yes,
that's
yes,
great.
yes.
Cool.
Thank you very much. It was great.
And
You've been great. Thank you so much, you too. That was wonderful.
For this reason,
Coming up next, a coffee break. Come here back at 2:15. Thank you.
don't forget the sponsor booths, lightning talks, and of course, junior band donation.
Yeah, there's still 6 free slots. For
They're
lightning
waiting
talk.
for you.
If you don't write for lightning talks, Tony will make lightning talk.
Yes, so probably
So now, for now, you will listen for 6 slots, Tony.
it's be a very,
Take some slots from him.
it's very cringy.